السلام عليكم ورحمة الله وبركاته. دكتور نضال الصالحي, University of Petra. Last lecture, we stopped here on slide 41, our chapter 5, Design of Goods and Services. Before I start with slide 41, I would like to remind you with something. If you still remember here in slide 39, there was a title to make or buy decision for the company. Yani the company sometimes has to take a decision in order to produce a certain raw material or to purchase that raw material from the supplier. That's why we call it make, to produce, or to buy. Now, going back to our slide 41, in order to take the decision of making or buying a certain material, we apply the application of decision trees to product design. Now we will apply this decision tree mathematical method in order for the company to take the right decision. Let's see an example. We will start with an example in order to explain things further. Don't worry about the size of the example. This is only an example for the purpose of explanation. Okay, I'll just read the example with you. Please listen to me carefully. Everything is given here so that you will understand what we are going to do and what we are after. Now, Silicon Incorporation, a semiconductor manufacturer, is investigating the possibility of producing, making, and marketing a microprocessor. Now, undertaking this project will require either purchasing, which is buy a sophisticated CAD system, or training and hiring several additional engineers. And this is, of course, make. Okay, so we have the purchase, which is the buy, and we have another option for the company. They have another option. Instead of purchasing a sophisticated CAD system, they have another option of making it themselves by training several additional engineers. Now, the marketing for the product could be either favorable, high sales in the future after we make the product, or unfavorable, which is low sales. Now, Silicon Company or Incorporation, of course, has the option of not developing the new product at all. They have another option, which is doing nothing. Now, doing nothing, of course, this is the third option. So we have three options: to purchase the CAD system, or to hire 3 engineers and to do the microprocessor and to do the raw material ourselves, which is the microprocessor. And the third option for the company is to do nothing. Now, with favorable acceptance by the market, that means high sales would be 25,000 processors selling for 100 each. So when we say favorable, if the market will in the future, the state of nature will be high sales, then we are expected to sell 25,000 units. Each unit we will sell it at $100,000. Now, with unfavorable market or acceptance, if the market has a low sales, then we are expected to sell only 8,000 processor at also $100 each. Now, the cost of CAD requirement, if we will purchase the CAD system, it will cost us $500,000. But that of hiring the other option of hiring and training 3 new engineers, it will cost us only $375,000. However, manufacturing costs should drop from $50 each when manufacturing without CAD system. Without CAD system, if we will do it ourselves, it will cost us $50 each. But with CAD system, the cost will be $40 per unit. Now, this is important here. The probability of high sales or favorable acceptance of the new microprocessor is 40% or 0.40, and the probability of low sales or unfavorable acceptance of the product is 60%. So there is probability of high sales 40%, probability of low sales in the future after we make the product is 60%. Let's see what are the requirements in our decision tree example. First of all, number one, we have to compute the expected monetary value, EMV, expected monetary value for the decision of purchasing a CAD system, and this is our first option. We are required also to compute the EMV for our second option, okay, which is hiring and training engineers, which is the make. And the third requirement is we are required also to compute the EMV or the expected monetary value for doing nothing. And doing nothing, now we answer it together, the answer will be 0, of course, because we decide if we decide to do nothing, then our expected monetary value, the answer will be 0. So the answer always in any question of doing nothing will be 0 for the EMV without solution. Now, and of course, after we calculate, we compute the two options here, and this is of course 0, we will select the best alternative. Our best alternative will be the highest EMV. Okay, let's start looking at the solution. It's a very easy solution if you concentrate with me. It's minus and plus only. Okay, this is our first option, to purchase the CAD, which is the buy, hire and train engineers, which is the make, and of course the third option of doing nothing, and as I told you, the answer here will be 0. Let's calculate the expected monetary value for the first option, which is if we decide to purchase a CAD system. Okay, here the probability, if you remember, here high sales, which means favorable market, low sales, unfavorable market. The probability here is 40%, as we said. The probability here is 60%. If you sum the 40% and 60%, will be 100%, which is 1. Okay, as probability. Now, sometimes in the question, if he will give you one of these, the other one will be the complementary, المتمم. يعني إذا أعطاك هاي 60 وما أعطاك هاي أكيد بدها تكون 40، وإذا أعطاك ال 40 أكيد الثاني بدها تكون 60. هذا بنسميه الكومبلمنتاري أو the complement of 40 is 60, the complement of 60 is 40, and so on. Now let's see. It's very easy. Now everything is given in the question, in the example, in the previous slide. First of all, let's start with the revenue. Okay, if you still remember, we will just calculate now everything for the high sale, and this is the calculation of the low sales, because we have two state of nature, future situation. Now, if we will calculate for high sales, if you still remember in the example, if the market will be favorable, which is high sales, we are expected to sell 25,000 units. Okay, multiply by 100, which is the selling price. Our selling price is 100. 100 multiplied by 25,000 units will be 2.5 million or 2,500,000 as our revenue. Okay, now of course, you know, if you want to calculate for the net profit, always you have to minus the cost. What are the costs? First of all, with the CAD system, the cost per unit is $40. So multiply by 25,000 pieces or units, the total cost will be 1 million. That's why it's in minus. You see the sign here. If it's minus, it's always a cost. So we have to subtract it. And we have also to subtract the cost of the CAD system. He told us in the question, in the example, that the CAD system will cost the company to buy the CAD system $500,000 or 500,000. So 2.5 million, okay, 2.5 million minus 1 million minus 500,000, our net will be 1 million as a net. This is in the case of high sales. But in the case of low sales, as it is given in the example, we are expected to sell only 8,000 units, if you can see. So the selling price is the same, 100. So 8,000 multiplied by 100 is 800,000 revenue, $800,000 revenue. Then we have to subtract also the cost now. The manufacturing cost will be only 40. Why? Because as we said, if we will buy the CAD system, the cost will be 40 multiplied by 8,000 units, so we will have a cost of 320,000, and we have again to subtract the price of the CAD system, which is 500,000. Then here we will have a net loss, which is minus 20,000, if this is in the case of low sales. Okay, now what is the probability of 1 million? This is in the case of high sales. The probability is 0.40. This is minus 20. The probability is 60. So we have to multiply now 0.40, the probability of high sales, by the net, which is the 1 million, as we can see. Okay, I'll show you here the expected monetary value for purchasing the CAD system. Our first option will be 0.40 multiplied by 1 million here, and then 0.60, which is the probability of low sales, multiplied by minus 20. Then we will have an expected monetary value, EMV, of 388,000. Now we will do the same for the second option, which is to make, which is hire and train engineers. We will do the same exactly. Here revenue, our revenue will be again $100 multiplied by 25,000 units in high sales. We are calculating for the high sales now, but we have to subtract the cost. Manufacturing cost will be 50 here, if you still remember in the example. If you will hire 3 engineers and you will make it yourself, the cost will not be 40 like in the CAD system, it will be 50. So 50 multiplied by our expected sales, which is 25,000 units, the cost will be 1,250,000. Now again, the cost of hiring, it will cost us to hire 3 new engineers and train them. It will cost us 375,000. So we have to subtract it also from the revenue. We have a net of $875,000. Now this is in the case of high sales. We will do the same for low sales. The difference only that instead of 25,000 units, we are expected to sell 8,000 units. That's why we'll have 800,000 as revenue, which is 80,000, which is 8,000 multiplied by 100. Then we have to subtract the manufacturing cost, okay, for selling 8,000 units multiplied by 50, which is 400,000. And we will subtract also the cost of hiring and training engineers, which is 375, the same as here. We will have a net of 25,000, and we have a net of 25,000. Then we have now to multiply the probability, which is 0.40 multiplied by 875,000 plus 0.60 multiplied by 25,000 as a net. Then we will have an expected monetary value, EMV, 365,000. Here, as I told you, the third option for the company is to do nothing. Of course, the net will be 0 because they will do nothing. Now, if you can see, our purchasing CAD system, the EMV is 388, but in hiring and training new engineers, it will be 365,000. So, which is higher? This by purchasing the CAD system has a higher expected monetary value. Then the decision of the company, of course, will be to buy or to purchase the CAD system. Okay, here as you can see, because it has an EMV of 388,000 versus 365,000 for hiring 3 engineers. That's why management should take a decision of purchasing the CAD system, because it has a higher monetary value of 388,000. Now this is for your homework, but I gave you the answer already here. Again, for the same company, all the given are the same except for the probability of high sales and low sales. It will be point, instead of 60-40, it will be 50-50. So if you will do it again, just for you, just to practice, please practice with that. I gave you already the answer. The answer will be the same decision. We have to purchase the CAD system, but the expected monetary value in this case will be 490,000. I give you this homework, and I give you the answer to check on yourself, just for you to practice. Now we have another homework, okay, but here we have three options, which is process to use to make process A, which is making by the company, or process B, okay. So first option process A, second option will be process B, and third option will be outsourcing, yani to purchase the raw material, okay. As you can see, you can read this question, but I don't want to waste the time in reading the question again. But here everything is given. The required is the expected monetary value for process A, which is make, expected monetary value for process B, which is make, yani it's make by the company, and the third option is to buy, okay, to buy the product instead of making it, yani outsource the product. And you are required also to solve the EMV. And of course there is a fourth option, but it's not written here. The fourth option, I wrote it in the example, is always doing nothing, and of course the EMV will be 0 for that. We know already that as the previous example. What is the best choice? Is it process A, B, or outsourcing, which is EMV, okay, or doing nothing? We will see. You have here the solution, okay. I make the solution for you in an easy way. The same in high demand, for example, the company is expected to sell $200,000 here, not units. They are expecting their revenue is expected to be 200, they are expected to sell 200,000 units. It's units, by the way, I'm sorry. Okay, multiply by, what is the 10? It's given in the example. 10 is the selling price per unit, minus the cost per unit. In process A is $4 only. So selling price minus cost multiplied by the number of units, it will give you the revenue, the same, minus the cost of making process A internally. It will cost us as a company 240,000. So we have a net in high sales or high demand. We have a net of $960,000. We will do the same in case of low demand. If you notice, in high demand we are expected to sell 200,000 units, but in low demand we are expected to sell only 100,000 units. But of course the selling price is the same, as you can see here, 10 minus 4 also. And of course the process itself, it will cost the company 240,000. So in the case of low demand, we have a net of 360,000. Now it's given in the question that for high demand, the probability, future high demand probability is 50%, and for low demand, the probability is also 50%. That's why if we multiply the 50% by the 960 and the 50% for low demand by the 360, we will have an expected monetary value of $660,000, and the answer is here, as you can see also. We will do the same for process B, but the cost here in process B will be $5, okay, and the cost of the process itself, it will cost the company 200,000 only. And we will do the same. We will multiply the 50% by the net, which is 800,000, 50% probability of low sales or low demand by 300,000, and we will have an expected monetary value EMV 550,000. Then we will also apply the same for the third option, which is instead of making it internally, okay, we will buy the product ready-made from the outsource. We will let somebody else who will buy it from our supplier, and in this case the cost per unit will be $6. There are no other costs except for the $6. Here again, the same 200,000 units we are expected to sell in high demand. Selling price the same. The price is 10 minus the cost, which is 6. So our net will be 800,000. In the case of low demand, we are expected to sell only 100,000 units, multiplied by selling price minus the cost, which is 6. So we have 400,000 as a net. Now this will be multiplied by the probability of high demand, which is 50 by 800,000, and of course 50 by 400,000. We will have an expected monetary value as 600,000. Now, as you can see, if we the alternative or the option of selecting or of process A is 660,000. Here in process B, our EMV is 550,000, and if we will buy the product or outsource the product, we will have an EMV of 600,000. So the highest expected monetary value is 660,000, which is our best solution. Why? So as you can see here, process A, it's the best. Why? Because it has the highest profit with an EMV of 660,000. Okay, now we will come to an easier topic, which is decision making tools, okay, in selecting or choosing a new product. Okay, we will use another tool, which is the break-even point analysis. And in break-even point analysis, at this moment, I want you only to look here. This is the quantity, okay, the number. First of all, as you all know, in break-even point analysis, always total revenue is equal to total cost. For those among you who does not know the meaning of break-even point, any company will reach the break-even point if their total revenue is equal to total cost. يعني بيسموها بالبلدي اللي هي الراس بطاقية، لا ربحان ولا خسران. ف you are required now, total revenue is equal to total cost. It means how many units do we have to produce in order to be break-even. So we need only, for now, of course, we need this formula. The quantity, يعني the Q here is number of units produced, is equal to fixed cost, okay, divided by fixed cost divided by the price minus minus V, which is the variable cost per unit, okay, which is the variable cost per unit. From as of now, I need from you, this is the formula. هذا اشتقاق طبعا للقانون من التوتال revenue is equal to total cost، لأنه هيك البريك even المبدأ تبعها. And here, this is the formula that we are going to apply. Now, this is the break-even point in terms of units. يعني how many units do we need in order to be break-even? يعني our total revenue will be equal to our total cost. Now, this formula, it will be used in other chapters. This is break-even point also, but in dollars. Instead of number of units, here in dollars, this one we will use it in other chapters. Today we will apply this formula. Remember, Q is equal as a break-even point, the number of units is equal to fixed cost divided by price minus variable cost. We have a question here, an example, sorry. An industrial company wants to produce a new product and the following data are available. You are giving the fixed cost, it's given. Variable cost is 60,000 per unit. Selling price is 100,000 per unit. The first requirement, what is the break-even point? اللي هي in terms of unit. Q, as we saw in the previous slide, Q as a break-even point, which is the number of units, is equal to fixed cost, it's given 240,000, divided by P, which is the price, which is $100, minus V, which is the variable cost per unit, it's given here 60. So we need to produce 6,000 units at least in order to be break even. It means to have our total cost is equal to our total revenue. Now another requirement, just for the purpose of practicing, what is the total cost? Of course, total cost always is equal to fixed cost plus variable cost per unit multiplied by the number of units, X. Now number of units is given, we know it already, 6,000 units. Okay, our fixed cost is 240,000. Our variable cost is 60 per unit multiplied by the number of units, which is 6,000, as you can see. So our total cost will be 600,000. So another question or requirement, what is the total revenue? Total revenue is always equal to the price, the unit price multiplied by the number of units. Our unit price is given, which is 100. Number of units is given also 6,000. So we have a total revenue of 600,000 units. This is just to prove for you that total cost is equal to total revenue. Why? Because total cost is 600,000 unit and total revenue is equal to $600,000, and of course total revenue is equal to $600,000. Now we still have a very simple tool for the decision making in choosing a new product. We call it the preference matrix. Preference matrix will use a certain criteria with an important weight for each criteria, which will be given based on the experience and personal judgment of the management or the expert. Okay, as you can see, we will have an example here, an easy example. An industrial company have 3 alternative products. The management, they have 3 options: product A, product B, and product C. So the management want to take a decision which product, which alternative to produce, which one is better for the company, using the preference matrix, نسميها احنا مصفوفة المفاضلة. Each product is given a scoring point ranges from 1 to 20. This is up to the company, يعني 1 to 20, 1 to 100 sometimes, 1 to 50, 1 to 10, whatever, based on a certain criteria as shown in the following table. Look here. We have criteria 1, 2, 3, 4 criteria. Okay, this is of course developed by the company. This is given in the example. They give also importance weight. For example, return on investment, the importance weight is 0.30 or 0.3. Contribution to profit margin 0.2. Competitive advantage as a criterion importance for the company is 40. Notice that the competitive advantage is very important for this company because they give it a 0.40, which is the highest. The compatibility with current production equipment is 0.10 or 0.1. So the sum is always of all importance weight is 1, as you can see. Here product A for example, هاي علامات أنا بمثلها لك من باب الدعابة. علامة product A مثلا في الكريتيريا الأولى علامته جاب 4 بس هذا جاب 6. product B, product C جاب 12 عليها، وهكذا. هاي السكور لكل واحد علامته حسب هاي الكريتيريا من 20. يعني this one for example for product A, this is the highest, very important for them is the competitive advantage، جاب علامة 16 من 20. Okay, and so on. Let's see the solution. Simply we have to multiply the importance weight by the score. So 0.3 by the score of 4 for this criteria, the first criteria is 1.2, and 0.2 by 10, 2, 0.4 multiplied by 16, 6.4, 0.1 multiplied by 8 is this. So the total weighted score for product A will be 10.4. We will do the same for product B. The total will be 6.8, and we will do the same also for product C, and the total weighted score will be 12.2. And of course your decision. What is your decision, guys? Now of course the decision of the company will be to select product C as the best alternative. Why? Because it has the highest weighted score, which is 12.2, as you can see here. So the decision is to select, okay, product C because it has a very high score compared to the other two products, which is 12.2. This end our lecture for today, and end of course chapter 5. Next lecture inshallah we will start with chapter 7, titled process strategy. The title is process strategy. And حتى ذلك الوقت, until we will meet again in another lecture inshallah. I hope that you will be always all fine. بتمنى لكم جميعا السلامة. Thank you very much.